We're only going to do part 1 today. We're going to finish the process tomorrow. We're only going to focus on the left-hand side of the equal sign. Tomorrow we'll bring in the right-hand side and complete the process. So this is only the first step in a process that we're going to be doing. And that is basically turning something into a perfect trinomial square. The perfect trinomial square is going to be either x minus some constant squared, or it could be x plus some constant squared. That's what a perfect trinomial square is. And that's what we're going to be focusing on. We've seen it before, and we've seen it on the previous page. This is the variable expression. This is a perfect trinomial square. It's x plus some constant squared. So here we go. We're going to start out as to how we come up with the formula. There's going to be a formula to do this. If I were going to be looking at x plus y, the quantity squared, this would be x plus y times x plus y, which is x squared plus xy plus xy plus y squared. Notice I've got the inner outer is repeated twice, so this becomes x squared plus 2xy plus y squared. Now this is what I want you to notice. If I take the square root of x squared, I get what's in the front of the parentheses. If I take the square root of y squared, the first and the last, that's what's in the back. The center sign is what's in the middle. The question ends up being, how in the heck do I find what I need if I have x squared plus 4x? I want to add something so that it's going to become a perfect trinomial square. That's the goal. The middle term holds the key. That says, when I look at the middle, it's got a 2 and an x and a 1, essentially. 2x. I want this guy, because when I square him, that's what goes here. But I notice I have an x already. So this would say that that middle term, 4x, has got to be equal to the middle, which is 2xy. Well, I already have an x, so it's gone. The term that I'm looking for that gets squared and gets put there to be a perfect trinomial square is what happens when I divide both sides by 2. That says, if I square 2, this would become a perfect trinomial square. Why? Because this y is the square root of the guy that goes here. Square him, I get this. If I could find what that is, then I know what that goes there. It's the square of it. So that says if I have x squared plus 4x plus 4, it should be square root of x squared is x, center sign is plus, square root of 4 is 2 squared. Suppose what I have instead is x squared minus 6x. I want to add something, so this becomes a perfect trinomial square. Now the coefficient of x squared is always going to have to be 1 in order for this to work. Well, what do I need to add? Well, remember that this center term, 6x, is the center, 2xy, while the x's go. That says what I need to add will be the square of 6 over 2, or 3. So what goes here is 3 squared. So the square root of x squared is x, the center sign is minus, the square root of 3 squared is 3, it's x minus 3, the quantity squared. So in general, to complete the square, take the coefficient of x, which is b, divided by 2. That removes the doubling. So this is the coefficient of x divided by 2. This removes the doubling. And square it. That gives you what you need to add. You take the center coefficient, because it's double what it needs to be, because you have the 2 xy's, so you got double what you need. So you take the coefficient of b, divide it by 2, that removes the doubling, and square it, and that's the term that goes right here. Now it really is easier to work with it than it is to see where it came from. But now you know where it came from, whether you are happy about it.